2 times by 5.5 times by root 13 times cosine 69. A few of you wrote sine 69. Be careful with your formulae. And simplify that. That should equal about 2904. Take the square root to get x. And we get about 5.39. Now we're going to use the sine rule to work out alpha. So sine alpha over 5.5 is going to equal the sine of 69 over x. So rearrange to make sine alpha the subject. We end up with that, and use the calculator, take inverse sine, and a lot of you wrote the answer 7234, but once again consider the ambiguous case, which is 107 and 66. Now 107 and 66, if that's our angle alpha, you add 69 to that, we are still under 180. So therefore there will be a third angle. So both of these are possible. A number of you left off that second answer. Number 15, there were two parts. Right? It says both in bold. We have part 1 and part 2. So for part 1, the domain, the x values. Every x value is being used except at x equals -2. So the domain is the set of x such that x is not equal to -2. And the range. I won't be fancy anymore. What is the range? The y value is lower than this value and equal to, and the y value is 1. So y is less than or equal to 1. Concavity. Where is the curve concave? This section is concave, this section here, up to the point of inflection. Once you hit that point, the graph is turning the other way. It's not going to turn upwards like this, as some people suggested. It will approach the asymptote, so it's always going to be convex after here. So therefore, it's concave everywhere to the left of this point, which is left of 6. So therefore, concave for x less than 6, I believe I accepted equal to, and we only have x not equal to -2 to consider. This function, you put that into your graphics calculator and you get a graph that looks somewhat like that there. And this value, the x-intercept, is 2.5. So therefore the domain will be x is greater than or equal to 2.5. The range, the y values are greater than or equal to 0. And the concavity occurs everywhere. Some people said x and r. It doesn't occur here. Therefore, we'd have to say that's x greater than or equal to 2.5. Substitute -2 in place of x. We'll get 3 take 4 times by -2 becomes 3 plus 8, 11. Sub x plus 3 in place of x. We have 3 take 4. X is replaced by x plus 3. Expand brackets. Collect like terms. And we have -9 minus 4x. G of f of x. First up, sub f of x, which is 3 take 4x. Now we go to the g function. We don't write x anymore. We write 3 take 4x. So it's 3 take 4x squared take 2. 3 take 4x plus 1. Expand and collect, and we end up with this quadratic. Part 4. Let's work out f of 2x take 4, which means put 2x take 4 here. So we have 3 take 4 times 2x take 4 equals -5. That's an equation which we can solve. Expand the brackets. Now collect like terms. Make x the subject. Divide by -8. So x equals 3 is the solution. Alright, last question, number 18. You've got to show that's the volume. The volume would be length times width times by the height here. So what are these three dimensions? That length there would be 80, subtract 3x. This length here would be 60, take away 2x. And then we multiply by the height, which is this length here, which is x. Now we can't just write the answer as given here, we need to show the steps. So 80 times by this lot here, and now collect like terms. Which is what we were meant to end up with. Now part 2, any restrictions? We know that length must be positive, so x must be greater than 0, but we know that x can't be more than this length here, nor that length there. So we know that these two values, 80 take 3x and 60 take 2x, have to be greater than 0. Now if you solve both of those being greater than 0, that will tell us something. So if I worked out 80 take 3x is greater than 0, I'd end up with 3x over this side becomes a plus 3x, got less than 80. So x is less than 80 divided by 3. If I consider the other equation, which was 60 take 2x, that must be greater than 0 again. That will give me 2x is less than 30. Sorry, I mean 60. And then x is less than 30. Now, comparing these two, 80 on 3 is in fact, what's that, 26 and 2/3. So if x is less than 26 and 2/3, then we can't have this as part of our solution. So I know that x is less than 26 and 2/3, but it's also greater than 0. So that is what you need to say about x. Drawing a sketch, I shall do it roughly here, but you should be using a ruler, and that's not too good. That's better. Label the axes. We have volume, and we have x, and if you draw the graph on the calculator, you get a graph that looks somewhat like this one here. It goes under a little bit there and back around. Now, using your calculator, you can work out the maximum occurs when x is 9.40 and the maximum volume is 20,061.11 metres cubed. Subbing in x into 80 take 3x and 60 take 2x will give us the width and length, and we end up with dimensions of 9.4 by 41.2 by 51.81 metres. All tests need to be passed up. I need to keep your test for moderation purposes. Hopefully you've added your results and checked that what I gave you was in fact correct. If not, it may be too late.